Page 6 of functions addendum. So number 4, we're going to solve these equations using the calculator. Okay, so basically what we're going to do is we're going to graph these two functions and see where the intersections are because it says equal here. Okay, so I'm going to do the first one step by step so you can see which screen to use. You press Y equals to get to this screen. You're going to put the left side and the right side separately, the left side in Y1, the right side in Y2, for example. You're going to put in the absolute value function by going to math and to number. Yeah, the number menu has the absolute value function. And then you're going to put in x plus 2. X plus 2. And then you're going to get the next function, and you're going to put 2x plus 1. 2x plus 1. And then you're going to graph them. And the absolute value function looks like a V. And the 2x plus 1 function is a straight line. And basically what you want to know is where is this point. And you can do that using second calc intersect. And the first curve is the absolute value function, yes. Second curve is the line, yes. What's your guess? It doesn't matter because there's only one intersection, so it doesn't matter where you guess. Normally you try to guess close to it, but you only have one intersection, so it doesn't matter. The intersection is 1, 3. So 1, 3. Now you have this other function here, and I'm going to input it offline. So I'm going to pause. So I input the left side, absolute value of x minus 2 in y1, and I put the right side, 2/5 x plus 1. Be careful to put parentheses around the 2/5 or use the vertical fraction, because if you put 2/5x, you never know what the calculator is going to do. Graph. There's the absolute value. There's the line. Oh, there's two intersections. So now I'm going to have to be careful about the guess. So I do second calc, intersect, which is number 5. First curve is the absolute value, yes. Second curve is 2/5 x plus 1, yes. And your guess, now I need to position the guess close to the intersection I want. I want this intersection first, so I position it close. I hit enter, and it tells me that the intersection is 0.714 and 1.29. So I'm going to write that down. 0.714, comma, 1.29. Okay, so that's one of the intersections. And the other intersection is this one here. Let's do that one. Second calc intersect. Oops. Second calc intersect, which is 5. First curve, absolute value, yes. Second curve, 2/5 x plus 1, yes. And now I'm going to put the cursor close to the other one by using the left-right arrows. And now it tells me this intersection is 5, 3. So that is the other point of intersection, using the calculator to find it. Okay, now these others we're just going to do using by hand. Okay, so first, remember that if you have absolute value is less than 4, then that's the same thing as absolute value is less than 4 in the case that x is greater than 0. And in the case that x is less than 0, it's actually the opposite of x because the absolute value is going to take the opposite of what's in there. So you have these two cases. The x is less than 4 case, that's already solved, right? The negative x less than 4 case, we just need to multiply both sides by -1. And when we do that, we're going to get x is greater than -4. So there's two parts to this. There's the x is less than 4 solution, and there's the x is greater than -4 solution. And in this case, both of them are going to you can satisfy both of these at the same time, right? So you can rewrite it as a single inequality expression. Now we'll do E. There's two cases for E. The inside the absolute value sign being greater than 0, that's one of the cases, and the inside the absolute value sign being less than 0, that's the other case. So when the inside is greater than 0, then we can write that as the absolute value sign doing nothing, because if the inside is positive, the absolute value sign is not active, the absolute value doesn't do anything. And so, let's see, we're going to do algebra here, subtract 2 from both sides, we get 1, add 4x to both sides, we get 4x, and then divide both sides by 4, and we'll get x is less than 1/4. And then for this one here, we'll have the absolute value sign is doing something because the inside of the absolute value sign is negative. So it takes the opposite of what's there. And then, let's see, -3 plus 4x is greater than 2. 4x is greater than 5. X is greater than 5/4. Okay, so these two cannot be satisfied at the same time because it says x is less than 1/4 and x is greater than 5/4. Those are contradictory, right? But you could say that like either one or the other is going to cause the equation to be true. Okay, what about I? Let's do I. So we have 2x plus 3 over x minus 1. Now if you try to solve this one as we have solved these others, it gets pretty hairy because one of the things you're going to do is you're going to kind of cross multiply. You're going to multiply both sides by the denominator so that you have everything in the numerator. At the moment you do this, then you start getting into, ooh, am I multiplying both sides by a negative number because the bottom is x minus 1 and we don't know what x minus 1 is, if it's positive or negative. So the one clever way to solve this problem is you say, okay, I'm going to square both sides. If I square both sides, then I know that both sides are positive, and I haven't done anything to change the inequality direction because I've just taken a bigger number, made it bigger, a bigger number making it bigger, or if it's a smaller number, I'm making it bigger, but not as big as I made this, right? So squaring both sides, when you have a for sure positive number here and a for sure positive number here, is not changing the inequality. Now, why don't you do it all the time? Well, because, you know, you're creating more work for yourself. If you're doing like FOIL or something on this, you're just creating a quadratic and you're making yourself more difficult. But in this case, maybe it's okay. Okay, maybe you're not making your life more difficult. So let's try that. So we're going to square both sides, and then the top is going to become 2x plus 3 squared, and the bottom is going to become x minus 1 squared. And the right side is going to become 4. And we don't have the absolute value sign anymore because we squared everything, right? Now we can multiply both sides by x minus 1 quantity squared, and we are not, we don't need to worry about changing the direction of the inequality, right? Okay, now let's expand using FOIL. Actually, this is going to be 12x, right? Plus 9 is greater than or equal to x squared minus 2x plus 1, 4x squared minus 8x plus 4. Look, that's a happy coincidence. The 4x squareds cancel out. We end up with 12x plus 9 is greater than or equal to minus 8x plus 4. So we were afraid we were going to get quadratics, but in the end they set it up for us so that they cancel each other out, and we're fine. So now we're going to add 8x to both sides. We'll get 20x. We'll subtract 9 from both sides. We'll get minus 5. X is greater than or equal to negative 5 divided by 20. X is greater than or equal to negative 1/4. Okay, that wasn't so bad. All right, let's go to C. We have absolute value of x plus 3 is less than or equal to 1. So there's two cases, right? One is that the inside is positive and the absolute value doesn't do anything. And the other is the absolute value is negative, or the inside of the absolute value is negative, and then the absolute value is taking the opposite of whatever's there. So we have x minus 3 is less than or equal to 1. X is less than or equal to, add 3 to both sides, we get x is less than or equal to 4. Negative x plus 3 is less than or equal to 1. X is greater than or equal to, subtract 1 from both sides, we get 2. So we get x is less than or equal to 4, x is greater than or equal to 2, so we can combine that into one inequality, which is x is between 2 and 4. Okay, that was C. What about G? G is a case also where maybe we could just square both sides, because there's two absolute values, kind of a lot to worry about. So we will say like 9x squared is less than or equal to 1 minus 2x squared. We're just squaring both sides. Since both sides are always going to be positive, it's okay to square both sides. You're not going to change the absolute value sign. So 9x squared is less than or equal to 1 minus 4x plus 4x squared. Subtract 4x squared, or subtract 4x squared from both sides. You get 5x squared. Let's add 4x to both sides, subtract 1 from both sides, and then we end up with that. Okay, so now we have maybe a factorable quadratic. Let's try to factor it. That worked, right? Is less than or equal to 0. Then we just need to find the critical points here and maybe do a sign diagram. So this one would yield 1/5 as a critical point, right? This one would yield -1 as a critical point. So we just graph the critical points. At both these points, there's zeros. In between -1 and 1/5, we have like 0. If we put 0 in here, we will get a negative number times a positive number. It's just negative. If we put big positive number, they're both positive, it gives us positive. If we put two big negative numbers in here, we'll get negative number times negative number, which should be positive. Okay, so I'm just going to rewrite that. It was messy. And then we say, okay, which part do we want? Well, since we're doing less than or equal to 0, we want the negative part. Since it's less than or equal to, we also want to include the critical points -1 and 5. So our answer is going to be -1 less than or equal to x is less than or equal to 1/5. Okay. Let's do K, which is the last one. Okay. So in this case, we have absolute value of x squared minus x greater than 2. So there's two cases here to work with. One is that the inside is positive, so we would have x squared minus x is greater than 2, straight up. Then there's the case where x squared minus x quantity is a negative number, so then you would find the opposite of that. Okay, that would be the other case, okay, because the absolute value sometimes would be active and sometimes it wouldn't be active. When I say it's active, I mean that it actually is taking the opposite of whatever's inside and instead of doing nothing. In this case, let's do a factoring and we get that. Okay, so that's one of the cases. And then this case, negative x squared plus x minus 2. Now in this case, I started to try to factor it, but then I noticed there probably wasn't a factor, and the way I can confirm that is I can do the b squared minus 4ac, the discriminant, and I can figure out if it's negative. And yes, in this case, the discriminant is negative. So if the discriminant is negative, that means that it never crosses the x-axis. So there are no solutions to this equals 0. And it turns out that if you put in any number into x, you'll see that you'll get a negative number. So actually, this is never true. So this doesn't lead to any solutions. There's no solutions to this. So that lets us concentrate on this one here, the x minus 2 times x plus 1 solution. So we'll mark those two critical points on the sign diagram. We'll try x equals 0 in there first. We get negative 2 times 1, which is negative. We try a big positive number, we get positive. We try negative number, we get two negative numbers, which is also positive. So it looks like this, and in the end, the region that we want is the region that is greater than 0, so that would be here and here. Would we include -1 and 2? No, we wouldn't, because it says greater than 0 and not greater than or equal to 0. So our solution in this case is that x is greater than 2 or x is less than -1. Okay, and there are no solutions from this path here. Okay. Number 7 says in part A to draw the graph of this crazy function with 4 absolute value functions in it. And if you put it in the calculator and you graph it, it looks like this, which is like a bunch of straight lines connected together by points, critical points at -5, 2, 0, and 3. Now I'm going to kind of go through an explanation of how you can kind of see that without the calculator. If you have this function here, do you notice how, like, let's say that you took a really big value of x, like x equals 10. If x equals 10, you can see that at that point, none of these absolute value signs are doing anything, because if x equals 10, then this is positive, this is positive, this is positive, this is positive, so there is no absolute value sign in effect. So what you could do is take off all the absolute value signs and add up everything, and you'll end up with 1, 2, 3, 4 x's added together. So part of your equation is going to be 4x something, okay? You don't know the y-intercept unless you add them up. But you know that the slope above x is greater than 3 is going to be 4, right? What if you took, like, to the far left? If you take to the far left, then each one of these, like, for example, x equals -10, at the region x equals -10, then each one of these absolute value signs is active. They're taking the opposite of what's inside, because if x equals -10, this is a negative number, this is a negative number, this is a negative number, this is a negative number. Every single one of these is going to be taking the negative of what's inside. So you can see that the x components, the x terms, are going to be negative x, negative x, negative x, negative x. So the slope here on the far left is going to be -4, right? What about if you put in a value that was between -2 and 0? If you put in a value that was between -2 and 0, like -1, then this value would be positive, this value would be positive, this value would be negative, and this value would be negative. So can you see here that in that case, the x term here would be it would be positive, because the absolute value would not be taking the negative of this. This would be positive. This absolute value would take the negative of x. This absolute value would take the negative of x. You add all these x terms together and you get 0. So in the case of -2 to 0, the slope is going to be 0. Okay? Now between 0 and 3, you would have like a number like 2. If x was 2, you can see that this would be positive, this would be positive, this would be positive, and this would be negative. So that would mean that the absolute value for this one would be active. So this would be a negative x, this would be positive x, positive, positive x. 3 positive x minus 1 negative x is 2x, which would mean that the slope is 2. By a similar method, you would find that the slope is -2. So you can see that, like, if you were to graph a function with these slopes, and they're all connected together, you would have a -4 slope, a -2 slope, a 0 slope, a 2 slope, and a 4 slope, and that's how you get this shape here. Okay? Alright, now let's move on. I'm going to just shrink this down because maybe we'll need the space. Okay, now in part B, it gives us an application of this formula here. So it says, if P, Q, and R are factories which are respectively 5, 2, and 3 kilometers away from this center factory, factory O, which we'll call the origin, a security service wants to locate its premises along this line so that the total length of cable to the 4 factories is a minimum. Okay, so if you were going to make an equation which figured out the distance from these 4 factories to any given point on the line, let's say that the point on the line is here, we'll call it x, okay? You can see that, like, the distances that you are going to be totaling is going to be this distance, this distance, this distance, and this distance. These are the distances you want to calculate. And you can see that the formulas for these distances basically x minus the position of the point here. So this one would be x plus 5, except you would take the absolute value because you would want the positive distance, right? Because maybe the x is going to be over here. You don't know, right? So this one would be x plus 5. This one here would be like x minus 3, and also with absolute value. So you can see that you actually are going to get this equation here when you calculate that. Okay? All right. So now that we see that this equation is actually the distance of, any given point on the cable to each one of these points all added up, we know that this is calculating the amount of cable you need between point X, we don't know where it is yet, and each one of these points, right? Okay. So we've just done number 1. Where should the security service locate its premises? What is the minimum length of cable they will need? Okay, so basically, Y gives us the total length of cable they will need. So what we want to know is when the cable is going to be at a minimum. So we could do that by looking at our previous graph, like this graph here. Look at this graph. So like this graph is at a minimum between these 2 points, between -2 and 0. So that would be between Q and O. So we know that the answer to locate its premises should be between Q and O. Okay, between Q and O. What is the minimum length of cable they will need? Well, I didn't calculate that in this graph, so let's calculate it by graphing on the calculator. So there's this flat part, the minimum part that we want. Let's just do a trace function because, with this kind of function, you have the luxury of just being able to go to any point in between these two and look at the y value. It's 10, and we know that the minimum cable amount would be 10 in that case, okay? All right. A fifth factory is located at point S, 7 kilometers to the right. Okay, so here we're going to have point S, which is 7 kilometers to the right. And if this is also a point that needs to be monitored, now where would you put the the control base so that it could monitor all these factories? You could change your equation now so that it also added absolute value of x minus 7 at the end. So we'll do that. X minus 7. Could it be 7 minus x also? Yeah, it could be, because 7 minus x, absolute value, x minus 7, absolute value, the same thing, right? So now let's check with trace where the minimum point is. So at the origin, the length of cable necessary is 17. If I go slightly to the left, it's starting to go up. If I go slightly to the right of the origin, also starts going up. So the minimum point is at x equals 0, and that is the only minimum point. So in this case, we need to put the factory at O. And that's the only possible place for the minimum cable length. Okay, and that's it for page 6.